where we left off, where I left off, we have a very basic setup now. In the main loop, every time we render a frame on the screen, we're asking our video reader to read out one new frame and to load it into a texture, and then we render it. Which means that because the rendering is actually about 3 times faster than, or maybe like 4 or 5 times faster than the frame rate of the video, we're getting this really sped up video here. So that's because we're not actually taking into account the information in the video file telling us when each frame needs to be displayed. And so we'll need to start doing that to get the right timing. So the way I want to do that, let's see. So inside the file, actually referring back to this tutorial, FFmpeg libav tutorial, he goes into a bit of details about PTS and DTS. Okay, so every time we receive a frame, we'll receive all of that data. So I'm gonna do that print inside our video reader. So we've received the frame. Here I want to do this little printf. To print out all of that stuff. Okay, he uses different variable names. CTX. So let's just do that. If we run this, every time we read a frame, okay, boom, that's a lot, a lot of frames. Oh, did I not print a new line afterwards? Or are they just really long? Okay, I need to add a new line. So, when we start decoding, each time we receive a frame, we receive the type of the frame. It's either a B, a P, or an I. I is the key frame, so that would be a frame that contains all of the data of the image. And then B will be a diff, and then P will be... So there are two kinds of diffs that we can have here. So, let me have a look. Does he explain B and P frames? No. Well, for our situation, we don't care about that because the decoder will give us the frames in the right order. But what we want to care about here is the PTS and the DTS. So they look to be identical, but DTS is basically the display time. Wait, let me make sure that I'm not confusing these two. Stack Overflow, perfect. PTS is best effort timestamp. Okay, DTS decoding timestamp, PTS presentation timestamp. So presentation timestamp gives us information regarding how, like, when this frame should be displayed. It should be 39,000 time units after the beginning of the video. So yeah. Okay, so what is the unit measure? The unit measure will be based on the time base. So if I go into my video reader here and I put a breakpoint on this one at the point of when we receive the first frame, essentially, then I need to open this up. Okay, so I have an AV. I don't care about the AV packet. I care about the AV frame. So in the AV frame, we've got the data, we've got the line size that we dealt with last stream. Then we get the PTS. And okay, so now I have to look probably in, not in AV frame, but in AV codec context, potentially. Where will I be able to find the time base information? Time base, there we go. 0 to 2. Okay, then that's not what we need. Where do we find the, maybe in the codec context, in the format context? No, it would be the information about the stream. So let's look at stream 0 inside the AV format context. Streams. Oh, jeez, Xcode. What is this? Why does it do this? Okay, stream 0 has an index, has a time base. There we go. So in the stream, the time base is numerator 1, denominator 25,000. So let's think about this for a second. So time base of stream 1 over 25,000. And let's say we have a PTS of 11,000. So we've got a frame where the presentation time should be 11,000 ticks after the beginning of the video. Then we multiply that by that time base, which would give us, well, 0.44. 0.44 seconds is the exact time we should present this frame, if that makes sense. So, yeah, that's it basically. I'm trying to figure out if I could do a really rough example to get the timing right, or if I have to do something complicated. Hopefully not. Hopefully I can do it quite easily. In the video reader state, what I'll add is our AV rational time base. And then when we read the frame, I'm going to give the state, the frame buffer, and I want to also get back the presentation time, the PTS. Is it an integer? I think it's an integer. Maybe it's an unsigned integer, but let me just see. What is PTS? Int 64. Okay, it's a long. So, in our read frame, I want to give back the presentation time of the frame that we just read on success. So, here, I will just say PTS will be AV frame PTS. Okay. And I want to put the time base in our context so that people can read what the time base is. So that would happen in the format here. Time base will be AV format context streams time base. So I have to probably get little variable so we can get that data. So now if I break in main after getting a video frame here, yeah, we have to give the PTS. Oh, why is this not working? Yeah, sorry. I could have checked the chat if I wanted to know the difference. Did I not update it in the header? In 64T pointer PTS. UN 64. There we go. I don't want to put a break there. Okay, so we're breaking after we read a frame. Our PTS is 0. And inside our VR state, we have our time base, 25,000. If I go to the next frame, PTS is 1,000, which works because the frame rate of the video is 25 frames per second. So if the PTS of the second frame is 1,000, that means it will be basically the first frame. How do I show that? 25 times 25, it's frame number 1. And 2,000, frame number 2, 3,000, and so forth. I could do a really stupid way of slowing it down, which could be funny. If I go here at the beginning of this function and I do glfw get time, which will give me a double of the seconds that have passed since the initialization of glfw. If I let's see, I want to know the time that the first frame was decoded and then rendered. So maybe I want to decode the first frame outside of the function. Wait. Okay, this is temporary, so I don't care if it's that ugly. First frame, true. And then here, PTS. Okay, so we decode our first frame, and here if it's the first frame, we're gonna have a double first frame time. If it's the first frame, then we want to set our first frame time. Or at this point, actually, with glfw set time to 0. If it's the first frame. And then never do that again. I could do maybe like that, static first frame. And so then we can get the time from glfw, and we can turn our PTS into the amount of seconds after the beginning that it should be shown as by doing PTS as a double multiplied by, well, actually we can do PTS multiplied by the denominator of the time base divided by the actually numerator divided by dominator, numerator divided by dominator. I'm getting so confused. Denominator, yeah, not dominator. That would be presentation time in seconds. I'll do PT in seconds. And so while glfw get time is bigger than PT in seconds, I'm just gonna do nothing. That's like, I'm just gonna spin at 100% CPU until we get to the right time, and then we display our video. Let's see if that works. Maybe it works, maybe it works. Maybe it doesn't. It's crashing. Oh jeez. Okay. I did something wrong. Does anyone know what I did wrong? So, okay, let me look at the chat again. So, on the first frame, we set GLFW time to 0. So we've got a counter that can tell us the time since the first frame was decoded. Then we do PT in seconds. Maybe this is supposed to be a double. Let's see. Oh, I think it's just the wrong way around. As long as the PT in seconds is later than the current time, we wait. So eventually it will be, there we go. Yeah. That seems to be running at the right speed. Like, obviously I can hear the fans of my laptop shooting up and it's at 100% CPU usage. So this is not very efficient. And is there any, like, what's happening to the memory? Okay, the memory is very slowly increasing. 100.9.6, 0.7 megabytes, 0.8 megabytes. Okay, I'm doing something wrong. The longer the video goes on for, the more memory is being occupied. So there's a memory leak somewhere. But that seems to be pretty much real time, which is great. Well, it's a really, really hacky way to get that to work in a really bad way, but it's a good start to getting the right timing. I have to find a way to sleep there. Anyway, what I will do is first figure out what memory might be leaking. So in our video reader, it must be happening in read frame. Yeah, here. We read a packet. If it's not the video stream, we continue without unreffing the packet, so it never gets deallocated. So I should unref before I continue there. And probably here also unref. .86 megabytes. 86.3. 86.6. 7. 8. 5. Okay, so it seems to be like stagnating around 87, 86, 83, 81, 87.3, 81, 87.1. Okay, there might be some other memory leaks that I need to find. But that seems to be okay. No, now it's 97. Why is it 97? I resized the window and it probably allocated a bigger buffer. If I make this small, .4, and I go really large with this, 103. So seems pretty safe. Seems to be going in real time. I won't know because I'm not doing any audio output. I'm not playing the audio with the video. Yeah. Yeah. Yeah, it depends. I don't really want to be spinning up like that. It's true. But what I could also do is, like, let's say we've decoded a frame and it's not ready to be presented yet and we have to wait. Then we might as well also just decode some more frames. Or just sleep for a while and maybe just... So the problem with sleeping is that we might sleep for too long. Does GLFW have a sleep? Okay, what I could do is like wait events timeout. So it will, but then, yeah, that's correct. So then it will process events, and it will sleep if there are no events, and it will stay in the loop until the time has passed. And so the timeout there could be PT in seconds. Wait, let's say GLFW time. GLFW time equals to get time. And then here we do a timeout for PT in seconds. Who cares? I'll just reuse the variable. I'll call it again. PT in seconds minus get time. We'll sleep for that long. So instead of 99% utilization, it should be 40. Okay. So we're sleeping for a lot longer. I don't know if that sleep function is accurate. If we will end up delaying these frames by too long. It looks fine. I don't think anyone would notice. Yeah, that works. That works actually.